Hey, this is Christoph, and I'm going to be doing week 8 and 9 updates in one video. I didn't put out a video last week, but I'll review both weeks' worth of progress here. So, to begin with week 8, the big milestone was objects. So now I can finally store things on the heap as opposed to the stack. So previously, I have this notion of a value, and values could have been floats or they could be a boolean, right? And I have different types that represent that, such as booleans, nil, which is the value of 0, and then value number, which could be any number that fits into an F32. Now I have this additional value kind called value object, and that's what you see with this O here. This was pretty tricky to implement because of the different paradigm of storing things on the heap. I essentially needed to create some sort of mechanism where any object could be stored on the heap. So I did that using something called a trait object, which is what Rust it's how Rust tries to mimic some object-oriented programming in terms of interfaces, I believe. So I have this thing called object handler, and basically any type can implement object handler, and right now I just have strings doing that. And this basically tells Rust that, okay, strings are allowed to be stored on the heap, and we're good to go. Yeah, this isn't a lot of code, but it was tricky because I had to deal with generics, lifetimes, and also, as you saw at the top here, there's this manually drop trait that I have to surround my RC in. And the reason that's because RC stands for reference count. It's unique to Rust because it lets you have multiple references of the same object. So what happens is every time I have a reference to RC, it increments a counter. So for example, if I had two variables pointing to RC, RC's value would be 2. Every time one of those values leaves the scope, the RC value would decrement. With manually drop, I have to manually free the memory of RC whenever its reference count is 0. So that was a bit tricky to implement. All in all, this amounted to this bit of script working, and I have string concatenation working. I could also do something like this. You can see that it evaluates to true, or if I would add more to this, you would see this not working out. False. So that works. Yeah, and that was basically week 8. Week 9, I started working on yesterday and today. It's pretty much just a lot of coding to implement my own hash map. Yay! I've never had to do this myself, and it was a really good experience. I'm calling it a table just because that's what the book calls it. But essentially all it is a fancy array that uses a hash function to store any key value pair. So an example of that would be I'll show you the hash function first. So I use the fnv1a hash function. Never heard of it before, but the book recommended it. It's pretty simple, only a couple of lines of code, and I was able to find some repositories on the internet to get a good test base to see if my implementation was working. As you can see, if I were to run this, it works. Ignore this bit of code here. It's a bit messy. I'm experimenting with that right now. I will say I haven't fully tested this hash map. I've kind of just written all the functions and gotten everything compiling, so that's probably my next step. As a side note, with regard to the hash map, you can do a lot of common things, such as like getting something, you can delete something. Deleting, it reminded me of archiving, actually, because instead of actually deleting the thing from the hash map, what you do is you give it something called a tombstone. And basically, whenever you insert an element into the hash map or the fancy array, you try to find a place to put it. And sometimes you try to put it in a place where there's already an entry. So that entry, if it was to be deleted, for example, would be considered a tombstone or archived. And that's just a really kind of neat trick to you don't have to basically reconfigure pointers and everything works as expected. You can do other things like insert. So if you wanted to insert a key value pair, that would be perfect. In this case, probably should change this, but in this case, you can insert anything that can be a value, as I showed before. And yeah, so there's a couple of helper functions, such as find entry. This is used when you're actually trying to find the index where you're supposed to put your new key value pair. And adjust capacity. I'm having to dynamically size this fancy array underneath the hood whenever I try to add something to the array and the size is not big enough. So I basically just double the size. But the trick here is that all my key value pairs in the previous array, they need to be remapped to the new array. And you need to do basically some additional calculation there, because the position of the entries is based on the capacity of the array. So when you grow the array, the entry size changes. Anyways, and lastly, I have this function here to add everything from one table to another table. I'm trying to work my way. I'm trying to write some good comments, and I need to test this whole framework out. But pretty soon I'll be able to do local variables, functions, closures, all that stuff in the coming weeks. Thank you for this update. Thank you for listening. And yeah, I'll see you guys next week.